Oh, yeah. Okay, this is the notes for 5-3 solving trigonometric equations. I will just quickly put up the first slide because I forgot to start recording. So if you want to see that heading, you can pause this, and otherwise it will be on the YOLA site as well. And then we're going to go on, and we're solving this trigonometric equation. So here is our problem. We have the sine of x plus the square root of 2 equals negative sine x. So we're using algebraic methods to first get the sine alone. So do you agree I might add sine x and subtract the square root of 2 at the same time? And so I get 2 sine x equals the square root of 2. I'll divide by that 2, so sine x equals the square root of 2 over 2. Negative. Thank you. Yes, I heard the negative, and then I had to process kind of where that would be. And so the sine of x is negative square root of 2 over 2 is what we're looking for. And that's on our table, so that's the good news. And then also we know that it's negative, so we have to kind of think of that dynamic as well. And we weren't given any directive for the interval from 0 to 2 pi or for all real numbers. So this means if there's no directive that we're finding a general solution. Find a general solution. And so that'll be like, our answer plus 2 pi n as we go through that. So just a kind of thought about that. And then all students take calculus. We have to look in that range, in that interval from 0 to 2 pi to see where this is going to happen. In what quadrants is that going to be negative? 3 and 4, and so we are not using those two. Our reference angle, when is the sine equal to the square root of 2 over 2? Pi over 4. And so our reference angle is pi over 4. That's neither of our answers as we go. So this is 4 pi over 4 right there on that axis. So when we go all the way to here, one of our answers is x equals 5 pi over 4. And for our second answer, I'm going to use the same little thing and just make a mess. And I have pi over 4 as my reference angle there, but I'm going to go all the way over. This is 8 pi over 4, and I'm going to subtract off pi over 4. So x equals 7 pi over 4. So those are our two answers in the interval from 0 to 2 pi. So that gives us two unique answers. And then to give our general solution, we get x equals 5 pi over 4 plus 2 pi n. And x equals 7 pi over 4 plus 2 pi n. So generally, one of two things is going to happen. Either I'm given an interval from 0 to 2 pi. In that case, that would have been my answer. Or if I'm not given an interval in which to work, then I need to give a generalized answer as I go. And I will have you exercise caution when you give that general answer, because in this case, it was just the sine of x. But if it's like the sine of 3x or 5x or something like that, you want to keep that 5 or 3x or whatever it happens to be intact at the point that we have our answer now, and then get that x alone. And we'll do problems like that, so that will not be an issue for you as we go. Then our next problem, I think, is just this homework help problem, just an extra problem to help with homework. And again, we haven't had one that has a multiple angle here for x. And so I do want to go over one like this because I think like 2 years in a row I had the similar question, so then I just put it in the slides. And so on the left of this line that's in the middle of the page, I'm going to do it in the interval from 0 to 2 pi. And then if it's all real answers, I'll do this to each answer, and I kind of just have that mapped out to help myself. So do you notice I didn't change the problem a lot, correct? So it's the sine of something equals negative square root of 2 over 2. So I have the same reference angle. I have the same sort of two values that I'm going to have there. And so I'm not going to redo quite all of that, but I will write it down. So my reference angle is still pi over 4, and my two angles that are going to give me that negative, oops, are the one that's right there. So x equals, I I'm gonna have to be careful here because it's not x that equals 5 pi over 4, it's what that equals 5 pi over 4, 4x. So if my interval is from 0 to 2 pi, at this point, after I've got my reference angle and I know where those two angles are going to be, I have to say that 4x equals 5 pi over 4. For this first one right there. And so then when I multiply by 1/4 is how I'm going to do that. And then I get x equals 5 pi over 16. So that would be one of my answers. And then if my interval is 0 to 2 pi, my other angle, which would go all the way around there, gives me 4x equals 7 pi over 4, same thing we had a minute ago when I multiply by 1/4 on both sides, then x equals 7 pi over 16. And so if my interval is from 0 to 2 pi, not including 2 pi, then my solution is this. The thing to be careful of is you don't want to take those answers that I circled in yellow and add 2 pi to them. Does that make sense to you? You have to add the 2 pi up there when it was still 4, because when it's still multiplied by 4, that's where I'm going to hit the place that I need to on that. So if I am asked to use all real numbers, then the just little thing I have to remember, and this is ahead of our real notes in this particular section, but it's close enough. So we have to say that 4x equals 5 pi over 4 plus 2 pi n. Because think about what happens now when I multiply both sides by 1/4 to get that x alone, then I'm going to have x equals, it's still 5 pi over 16, but instead of plus 2 pi n, it's going to be 2/4 or pi over 2 n plus pi over 2 n. So that's kind of the thing that we have to be careful with. And then I just said do the same with, and that's with this other one. So 4x equals 7 pi over 4 plus 2 pi n. Just remembering that if it's not just a plain x, that you add the 2 pi n before you get that plain x alone. And that will help you, just not have issues with these kind of problems. So when I multiply by 1/4 again, I'll get x equals 7 pi over 16. So those initial values stay the same, but then instead of adding 2 pi n, I'm adding, in this case again, pi over 2n. Oh, I wrote pi again instead of n. So that's just an extra problem to help with homework because it came up enough, and I know otherwise in the notes that we do, maybe it won't be super clear that these things have to happen like that. So I wanted to make sure we went over one like that. And then our next two problems are a tangent problem and a sine problem. They have sine squared and tangent squared, but we're just going to solve that and get it alone. We don't have to factor like a quadratic because it doesn't have a tangent term, a tangent x term or a sine x term. We'll have that in kind of our next thing. And also just a reminder, the period of tangent is pi. So we're just going to go to pi and then kind of think about what our generalization is going to be from there. So our first job, 3 tangent squared x minus 1 equals 0. Add 1, divide by 3. So tangent squared x is 1/3. Square root both sides, and then, of course, remembering that it's the positive or negative square root. So tangent x equals plus or minus the square root of 1/3. And so tangent x equals plus or minus the square root of 3/3. So the square root of 1/3, 1 over the square root of 3, and then rationalizing that denominator. So this is a plus or minus, so we are still going to get 2 answers, but our 2 answers will come within quadrants 1 and 2. All students take calculus, because once we get those, then it's just a repeat after that. So because it's tangent, we'll just be repeating after pi as we go through this one. So I need to figure out my reference angle. So tangent will be positive there, tangent will be negative there. What is the reference angle if tangent x is the square root of 3/3? Pi over how much? Pi over 3. No. Pi over 6. It's pi over 6's. And, you know, here's the table of values, sine, cosine, tangent, and it starts right out as, well, 0 is there, 1/2 square root of 3/2, and then square root of 3/3. So 0 pi over 6 is the reference angle, is pi over 6. And so then my 2 answers, and I was just told to solve, so this will be going on. But since tangent repeats itself and it has a period of pi, once I find my answers, I'll just be adding pi n to them. So that's something to just be aware of. So my first angle is just pi over 6. So x equals pi over 6 plus pi n, since I want a general answer. And then my second angle, I'll use maybe purple, my second angle, oops, has that reference angle. Here's the angle. This is pi over 6, this is 6 pi over 6, so that's 5 pi over 6. So x equals 5 pi over 6 plus pi n. And so if you've kind of forgotten that table because maybe we haven't used it for a little bit, maybe just make sure you're refreshing your memory of it. Now, I want to just comment on this one. Do you agree, and I'll just use kind of yellow, that really these answers would exist, right? With a reference angle of pi over 6 and the reference angle of pi over 6. But so really, I could write this as 4 different things plus 2 pi n, correct? But since these are a linear pair, you know, or this makes a linear pair or a line, I guess, that these are pi over, or pi away from each other. So instead of doing this one plus 2 pi n and this one plus 2 pi n, we can just say, well, if I'm here and I add pi, I'll just get there, and then add pi, I'll get there, and add pi, I'll get there, and add pi, I'll get there. So that's why we want to do that. I would say making that mistake and giving 4 answers for tangent is kind of comparable to giving, you know, as an error, of saying like 2/4 is your answer instead of 1/2. Do you know what I mean by that? You're not giving, you know, we would say if you give 2/4 as an answer, I'll just say like a little algebra problem, you didn't simplify, right? And so this one you didn't simplify because we don't need all of those values. Sometimes with sines and cosines, you can do the same thing if you're having this positive and negative, and sometimes you can't. So it kind of depends on the problem. And we'll look at this one and kind of see what happens there. I think I can get through this one, and that was my goal today. So 4 sine squared x minus 3 equals 0. So sine squared x equals 3/4. Square rooting both sides, sine x equals plus or minus. Can I just say it's the square root of 3/2? Is that okay with you? Square root of 3/2. And so now in this one, I have all students take calculus. What's my reference angle for sine to be the square root of 3/2? Pi over 3. Pi over 3 is our reference angle. Since it's positive or negative, we actually do get, kind of all 4 of those answers. And it's this situation. Of course, this one, we know the period is pi. In this one, the period is 2 pi, so we want to kind of think about all of those. So we would have this version, which is pi over 3 plus 2 pi n. And we would have kind of this version. Oh, I always want to do the reference angle. There we go. This version, which would be 2 pi over 3 plus 2 pi n. And I'm writing these in an order so that it's easier for me to do things. And then this version, which is 4 pi over 3 plus 2 pi n. And then this last one, which is right here, this angle, but going all the way around, which is what? How many pi over 3? 5 pi over 3 plus 2 pi n. And do you agree that these two are related to each other by pi, correct? So instead of going this plus 2 pi n and this plus 2 pi n, I can just give pi over 3 plus pi n, and that takes care of both of those. And same thing here. I can take 2 pi over 3 plus pi n, and that takes care of both of these together over there. So just a little note to self that sometimes tangent is a little different because the period is just pi, but even with sine and cosine, we can kind of look at problems like that. And so it was my real goal to get done with this one, but we'll be here next time. Because there you go.